So the third angles theorem is an extension of our triangle angle sum theorem. It says if two angles of one triangle are congruent to two angles of a second triangle, and as you can see here, angle C is congruent to angle K, and angle B is congruent to angle J. Because each triangle's measures have to add up to 180, that means that the third angles theorem is saying that angle A must end up being congruent to angle L. This does show up in proofs, so I do want to go through a proof here to kind of demonstrate kind of all the ideas we've been talking about, both in section 1 and in this section. So here I have two triangles, triangle LMN and triangle PON, that I'm trying to prove are congruent. And I've been given some information here. I'm going to do this as a flow proof. So I have a lot of different givens here. So I have angle L is congruent to angle P, already marked on the picture. That's given. I have segment LM is congruent to segment PO, already marked on the picture and given. Segment LN is congruent to segment PN, already marked on the picture and given. And segment MN is congruent to segment ON, which is also already marked on the picture and given. Well, if I want to show that these two triangles are congruent, I need to show that all three pairs of sides are congruent and all three pairs of angles are congruent. I can see that I've got all three pairs of sides congruent because here's one, here's one, here's one. But I only have one pair of angles, so this means I need to show that I have more congruent angles. So one thing that my eye is drawn towards right away is I have vertical angles. I can see that these two angles are vertical, so they're going to have to be congruent by the vertical angles theorem. So they're both at n, so I do need to use three letters to name each angle. So angle LNM is going to be congruent to angle PN, oops, forgot the angle sign, angle PNO, because vertical angles are congruent, or the vertical angles theorem. But now I have two triangles where I have two pairs of congruent angles. The theorem I just discussed says that because I have two pairs of congruent angles, the third pair of angles will have to be congruent. So angle M is going to have to be congruent to angle O, and that's the third angles theorem. Well, I now have three pairs of parallel sides and three pairs of congruent, or not parallel sides, three pairs of congruent sides and three pairs of congruent angles. So taking all of this together, so here are my three angles pairs, here are my three segment pairs, I can now say that triangle LMN is congruent to triangle PON. And that is the definition of congruent triangles, because I showed all of the corresponding parts are congruent. Now, that's a lot that we have to show is congruent to say the triangles are congruent. Coming up in the next few sections, we're going to be finding shorter ways to show triangles are congruent.